Hi everyone, today is our first class for organic chemistry. Now, in chemistry we have lot of branches. One is physical, just a second, I need to reduce this size. First is physical chemistry, next one is inorganic chemistry, third one is organic chemistry. These are the main three branches. But apart from this one, we have several other branches. That one is the pollution chemistry, biochemistry, biochemistry, pollution chemistry, chemistry, industrial chemistry, medicinal chemistry, sort of, etc. Now, organic chemistry is the most vital part because this chemistry is involved in biochemistry, in medicinal chemistry, and also in a pollution industrial chemistry. But major role plays in biochemistry and medicinal chemistry. So we need to know the organic chemistry. In organic chemistry, we are basically dealing with carbon. Carbon is an element in a periodic table which is belonging in a group 4 elements. Group 4. If we consider the atomic number of carbon is atomic number of carbon is 6, and since it's 6, in neutral state carbon having 6 number of protons in a nucleus and 6 number of electrons in the electronic orbit or orbital, and mass number minus 6 number of neutrons are in a nucleus. Since they are since each electron having minus 1 negative charge, so total negative charge is minus 6, and each proton having plus 1, so total positive charge is plus 6. Plus 6 charge and plus minus 6 charge, they are cancelling each other, so they are neutral by nature. Now in neutral state they are not carrying any charge. Now in organic chemistry, majorly we see the carbon. So it is known as carbon chemistry. Carbon chemistry. But why it is carbon? Actually, carbon plays a major role in organic chemistry. But other than carbon, we see hydrogen, oxygen, nitrogen, sometimes sulfur. They are in a minor role. Why carbon is in a major role? Because carbon have some properties. Number one, catenation property. Catenation property. Number two, carbon having a capacity or capability to forming multiple bonds. Having capacity or capability to form multiple bonds. Having capacity or capability for multiple bond. And number three is isomerism. Let us start. Actual uh, this property. Let us start this property. Acha, before that, we need to know that is, we know that is one of the scientists actually synthesized organic chemistry from the inorganic molecules, and that inorganic molecules is known as ammonium cyanate, NH4CNO. Ammonium cyanate. Actually, ammonium cyanate is a inorganic compound. It basically ionizes and forms ammonium ion with cyanate ion CNO minus. That scientist has heated this ammonium cyanate and formed urea. Urea is C. Here is the formula of urea: C double bonded O NH2 and C double bonded O NH2, right? Or we can sometimes we can write in this way, that is CO NH2 twice. Now it's ammonium cyanate, ammonium cyanate, and this one is urea. Next, we need to know the what are the properties of carbon. The first property we need to learn, that is catenation. What is catenation? The property of the atoms of an element to link with another by stable covalent bonds to form straight chains, branch chains, or rings is called catenation. That means carbon having carbon having property to link with another carbon atom either through single bond or double bond or triple bond. তাহলে by these three type of bonds formation, carbon can make a covalent bond with other carbon. As a result, carbon can make straight chain compound, straight chain, straight chain compound, branch chain compound, and ri- ring type compound. Ring type compound. Next, we need to know catenation. This one is catenation, and this one is that is having capacity to make multiple bonds. This one is the example. Okay. In catenation, that is carbon carbon single bond, carbon carbon double bond, and carbon carbon triple bond, we will see that is in these three type of bonds, in carbon carbon C bond, the bond type is sigma bond. In carbon carbon double bond, one of a bond is sigma, another bond is pi. In carbon carbon triple bond, we'll see one is sigma, other twos are pi bond. What is sigma, what is pi, that we will learn later. Actually, the way the bonds are formed differs. When the two lobes are head-on collision or head-on overlap, the bond is formed is known as sigma bond. When the two lobes are parallelly overlapped, then the bonds are formed is known as pi bond. That we will cover. The next topic is third one, that is isomerism. What is isomerism? Actually, the phenomena of isomerism is when two or more compounds having same molecular formula, but they are different structure and different arrangement of the atoms in a space. Then phenomena is known as isomerism. Actually, isomerism is a phenomena. Mean two or more compounds having same molecular formula, same molecular formula, but they are different. Okay, great. The next chapter is the next one is our electronic configuration. We know that is in a periodic table we have in a group 4 element is carbon, and carbon have atomic number 6. These 6 electrons can be distributed in a two-dimensional figure, and that one is 2 4. I think we have already learned in our class 10. That is, we can in an atom we have two parts. One is part is inner part, which is known as nucleus, and the outer part, that is cyclic orbit. This orbit is known as cyclic orbit. This orbit is known as electronic orbit. Electronic orbit. This nucleus contains two subatomic particles. Two subatomic particles. What are the two subatomic particles? Proton and neutron. Proton is positively charged and plus one positive charge, and neutron is chargeless. And these electronic orbits are full of electrons, and electrons are negatively charged particles. From the nucleus, the orbits are K, L, M, and so on. So the nearest orbit is K orbit for everyone. In carbon, since the distribution 2-4 says, that is K orbit can accommodate two electrons here, and L orbit are having four electrons. Since L orbit is the last orbit for carbon, and this orbit is known as valence orbit. And this valence orbit, number of electrons in the valence orbit are known as represents valence. But this concept is a two-dimensional concept. We need to know the three-dimensional concept of electronic distribution. In two-dimensional concept and in three-dimensional concept, here is a difference in our electronic orbits. In 2D, we think that is electrons are revolving around the nucleus in a two-dimensional path, and that is the path naming is K, L, M, and so on. But in three-dimensional concept, electrons are in some area, some region, or better you can say some cloud. So three-dimensional concept is a cloud-based, orbit, region-based, and that cloud name is known as orbital. So difference in between 2D and 3D is orbit and orbital. Right now we will say that is every orbit having some orbital, but it will be much more clear when we will cover the quantum chemistry. Quantum chemistry. For now, we need to know That is, which orbit having which orbital. K orbit having one orbital, that is 1s orbital. L orbit having two orbital, 2s and 2p. M orbit having 3s, 3p, 3p. Now, since carbon having 6 electrons, wait, since carbon having 6 electrons, these 6 electrons are basically in a k orbit and L orbit. So the distribution is twofold. Now we know that is k orbit having only one orbital, that is 1s orbital, and L orbit having two orbitals, 2s, 2p. Now s orbital are round shaped orbital. So if it is 1s orbital, it will be a 2s orbital, that is much more bigger compared to 1s orbital. And p orbital are dumbbell shaped like this one. Actually, s orbital have not having any subdivision. Max to max, two electrons can be accommodated in each orbital. So we can say that is 1s orbital can accommodate 2 electrons. Similarly, 2s also can accommodate 2 electrons. But p orbital having subdivision, it is px, py, pz. We can represent in this box px, py, pz. Now, two electrons can are in in each orbital can accommodate max to max two electrons. So two electrons will be here, two electrons will be here, two electrons will be here. It's a maximum accommodation. Now these carbon having 6 electrons. So out of 6 electrons, 1s orbital will occupy, 1s orbital will accommodate 2 electrons, and these 2 electrons are clockwise anti-clockwise. Similarly, 2s orbital also having no subdivision, so 2 electrons will be here, that is clockwise anti-clockwise, but 2p having 3 subdivision, and each subdivision can accommodate 2 electrons. So here you have, out of 6 electrons, you have already accommodated 2 plus 2, 4. Only 2 electrons are left, and that 2 electrons will be here in a clockwise direction, here will be clockwise direction. Now here, why it is in this way, why not it's paired, that we will cover in a atomic structure, where we will discuss Aufbau principle and also Hund's rule, right? For the time being, just read that electrons, carbon having distribution is 1s2, 2s2, 2p2. This electronic distribution is known as ground state electronic distribution. In ground state, the electronic distribution of carbon is 1s2, 2s2, 2p2. But when the carbon is heated, it goes to the excited state. Actually, this one is a ground state and this one is an excited state. If we write the energy barrier in this way, where here it is 1s, this one is 2s, and this one is a 2p. We are trying to write in some box, and here is some energy. Energy is increasing from ground state. In ground state electronic configuration, two electrons are here, 2s having two electrons and 2p having one each. Now